we will discuss about binary search tree. Okay, so we will see like how basically binary search tree works. So here we have created a class called binary search tree, and actually we are implementing generics on that. And in that generics, here we are supposed to type the pass. So this type will must actually be implementing I comparable type. Means we are specifying that whatever the type that we will pass here, that must be implementing I comparable interface. Why are we doing that? Actually, in binary search tree, what happens basically, you will be inserting the record, and records gets inserted based on the values, like based on comparison actually. So every new node will be compared with the root node. If the node is a smaller, the value is a smaller, it will come to left side. If it is greater than, then it will come to right side. So this is how basically will work. So we, in order to compare whether the values are lesser or whether the values are greater, we are calling compare to method. Okay, so this compare to method is available in I comparable interface. That's why we are saying ki whatever the type will be here, that will be implementing I comparable. For example, we are passing here int, and this type has their own implementation of compare to. Okay, and so we are able to call the compare to method with this one. In the sense, we are saying ki now all the t, whatever the type will be t must be implementing the I comparable interface. And that's why if they are implementing the I comparable interface, they must have the implementation of compare to, and hence we are able to call compare to method here, because we know basically compare to method is coming from I comparable method, I comparable interface. So that's it. This is what we have. Now in a binary search tree, we have the data like node data, we have left tree, we have a right tree. Okay, and we have here result also. So this we will be using for another purpose. As of now, we will focus on these three variables: node data, left tree, and right tree. So let's try to understand now, and we will say how basically records are getting inserted in binary search tree. I will try to draw the diagram also, so that you will be able to understand it properly. So here if I show you, basically control will execute, in the console application, execution always starts from main method. So here I will run, and control will come here, where this message will be printed like welcome to binary search tree demo, and then it will follow. So I will say F10, this message will be printed, and here what we are doing, we are creating the object of binary search tree class. Okay, so if I press F11, basically this is a constructor call, and on this call only object allocation takes place in heap area. So constructor will execute, and if you see in this constructor what we have, we are whatever the value that we pass like 56, that 56 will initialize to this node data, which is nothing but this node data, a global variable, global non-static variable. Means currently this is the different, and this node data is different. As you can see, their spellings are also different. So likewise, so this node data is getting initialized, currently it is 0. And when this line will execute, and now if I hover, you can see the node data became 56. So when constructor executes, what happens, ki one object will be created, this object like this, and inside that there will be one variable called node data, and as you saw, this node data will be initialized to 56. And then they will have left tree. I will write lt indicates left tree, where if you see in the constructor, we are not initializing left tree and right tree, and they are non-primitive data type, which indicates that the default value of left tree and right tree will be null. Okay, so node data will have value 56, and left tree and right tree will have value null. So lt is null. Likewise, rt stand for right tree, which will also be null. And when object gets created, the address of this object will be something, that will be happening in the memory. So we are taking an example that 1000 will be allocated, and the name, let's just for the sake of simplicity, we will keep their name as a object. So this is what basically will be happening on the execution of this line. Now once this executes, object allocation takes place, memory allocation will take place. Okay, along with that, it will also return actually the address, and that address basically will be stored inside the binary search. So this is the reference variable will be holding the object of type binary search tree. So in here somewhere a reference variable will be created, and then this is the 1000 as a address of object a will be assigned to binary search. If diagrammatically I show you, binary search will start pointing to a object. So this is how basically will be happening on the execution of this line. That's it, nothing else. Now we are saying binary search dot insert. Since binary search is pointing to a object, means this time we are saying insert method should be executing for which object? A object with value 31. So now when I press F11, insert method will be executing, and remember what will be the type of T? This T was placeholder in beginning, but now during the time of creating object, as you see here, we told binary search tree and we passed the int. Okay, so now wherever you see the t, all the t will automatically start behaving like int type. Okay, so this t became int. And also, does it mean that this condition should be applied? Yes, this condition is also getting applied on int. We were telling कि whatever the type that we will pass here, they must be implementing I comparable. Currently, we are passing int, and we are expecting that this int must be implementing which interface? I comparable interface. Currently, we are not getting any error. Let's check whether int is satisfying that criteria or not. So I will right click on int. I will say go to definition, and if you see guys, so this int basically is implementing I comparable interface. Means whatever the condition that we give there, that if we are passing int at place of t, that should be implementing I comparable. You can see int is fulfilling that criteria. Means int is implementing I comparable. Since int is implementing I comparable interface, it means this int must have their own implementation of compare to method, this method. Okay, you won't be able to see the logic, but definitely int has their own implementation of this compare to. And to use this method compare to, we have kept this condition. Okay, because if you want, currently you see, to check we are using the compare to method, and this method can only be utilized when I comparable is implementing, so that you will have the implementation of compare to. And you saw that int is fulfilling that criteria. So all those data type which will be implementing I comparable interface, those data type you can pass here. So currently we are passing int, assuming our binary search tree will be holding values of type int. As soon as you are passing int, automatically all the t, wherever you see the t, all the t will start behaving like integer type. Okay, so if I ask you what is the type of this node data, you should tell it is of type integer. What is the type of this node data? T, and t is behaving like int, so automatically this type will have int. Everywhere wherever you see the t, all t will start behaving like int. So of course this item will also be of type int, because currently t is acting like int type. Okay, and if I hover, we are calling this 31. Means when we call this insert method with value 31, this will come and it will execute the value of item is 31. Means we want to insert this record 31 in our binary search tree. question is, in order to insert, what basically we will be doing, like, the number will be compared with the root node. Okay, and in our root node we already have 56, and we know the rules of binary search tree is, if number is greater than the root node, it will shift to right side. If it is lesser than the root node, that is 56, it will shift to the left side. So this is how records inserted, but we will try to understand the logic and will go according to logic to make sure whether our logic is right or not. So here we will have this, and again, this dot node data, what we are doing, we are trying to find the value that is present in the root node. Currently this will be pointing to current class, which is nothing but the class of object of binary search tree, or you can simply assume the root node, which is nothing but a object. Okay, so a node data, value of node data in object a, so value of node data in object is 56, and the same 56 will assign to current node value. You should not get confused that what is the type of this. As you already know, currently t is acting like integer type, so this will be of int type, and in this we are assigning this 56. Okay, so if you see the next line, we have here, in this, 56 got assigned to this also. Current node value is 56. Okay, now 56 compared to item, so this became 56 and this is the 31. So you need to understand how compare to method works. Actually, compare to method currently will be working for integer type, and integer type, in int, float and double, it has been, implemented in such a way so that compare to method will return -1, +1 or 0. These are the three thing values that will be returned by compare to. Question is, when it will return -1, when it will return +1, and when 0. Actually this is the instance and this is the value. So when this instance is greater than the comparing value, in that case it will return +1. If this instance is lower than the comparing value, in that case it will return -1, and if both are same, it will return 0. You can also understand in another way by, just by subtracting the values. This is for just a hint, you can say. This is a trick so that easily you can find out, like, when compare to method will return -1, when it will return +1, and when it will return 0. Simply, you leave both values as it is. Okay, like currently we have node value 56 and item is 31, so don't touch them. Just put dot compare to with minus, so just put minus here, and now you calculate the calculation. 56 minus 31, of course value will be some positive number. So if number is positive, you should assume it will return +1. If suppose this value could be lower, okay, any value, maybe 31, you could be here, and here it could be 56, reverse. In that case, when you will compare, when you will subtract, then value will be negative. So in that it will return -1. Okay, and when both values will remain same, in that case it will return 0. So this is a trick that you can follow to understand the implementation of compare to. In int may, in int also have the same implementation like this. A float also and double also have like this kind of implementation only. So currently now you understand 56, and if you want to quickly find out, it will return what? So -31. Result will be some 56 minus 31. You will get some positive value. So it will be evaluated to compare to will return +1. And of course this expression will be +1, means 1 is greater than 0. Condition became true. So control will come inside this if block, and now this dot left tree. So this is nothing but again the current object, the root object. Okay, so here we are saying, go and read the left tree property of current object, root object, or in our example a object. So if you see, the left tree is set to null, okay, of current object. So left tree, this evaluated to null, and this also became null. Null is equal to null, condition became true. So control will come inside this. And now here if you see, we have this, like one another object will get created of binary search tree with item value 31, because after comparison we got to know item is a smaller. If it is a smaller, it should be kept inside the left side of the root node. Okay, so one object will be created. If I press F11, you will see constructor call will take place here. So F11, and here constructor is going to be executed. This node data 31 will be used to initialize this node data, and they will also have a value 31. Currently it is a 0, but when this line will complete their execution, you will see this node data will also have 31. Let's press F11. This line executed successfully, and now if you see, so this node data became 31. Okay, so this is how basically one another object will be created if I show you. And inside that, the node data value will have a 31. And then here lt I will write in short, a left tree I will write it as lt. And we are not initializing to left tree and right tree for this newly created object, right? We initialized the node data, but we have not initialized left tree and right tree. So these two variable always remain in their default state. Okay, guys, this is also a part of object only result, but currently we are not utilizing, so I am just ignoring this. But you have to assume that this variable is also present in every object. Okay, just to make the picture clear, I am ignoring this one as of now, but you have to assume this is there in object. Okay, currently these three are important, and so I am considering only these three. So left tree and right tree, even if I hover, you see we are getting null, which is default value, because we are not initializing them yet. So lt will have a value null, as well as rt stand for right tree, which also have values null. And by default, if object gets created, definitely they will have some object address. So we assumed 2000 is the address, and let's keep their name also maybe b. Okay, after this object gets created, you can say it will return the address, and that address will assign to left tree. Which left tree? This dot left tree means current object, which is nothing but root object. Okay, so left tree of root object will be getting this address. This address currently in our example is 2000. Okay, so this 2000 will assign to left tree of which object? A object, root object. So this left tree means null will be overridden with the value 2000. So here it is 2000, and now this lt left tree will start pointing to object b. This is what basically happening on the execution of this line. After that, since this if was true, this else will be escaped, and then even this if was true, so this else part will also be escaped. So here escaped, and we are able to successfully insert the record 31. And 31 was lower, so it should come to the left side. In binary search tree, every node will have maximum two node. Okay, if the number is lower, will come to left side. If the number is greater, will come to right side. This is how basically records will be inserted in binary search tree. Let's go and iterate trace the code for insert as well. So here again we will call, and we are saying binary search dot insert. Binary search is still pointing to which object? A object. This is the reference variable. Binary search is pointing to a object. Okay, and this insert method is getting called for which object? A object only. Means keep in mind, the current object is which object? A object, because we are calling with binary search dot insert means ki binary search is pointing to a object, and for that object we are calling insert method. So our current object will be a root object only and value is 75. So this time again this will be pointing to the root object. As I told you, this means current object, and currently our current object is nothing but is a object. As you saw, using binary search we called method insert. So our binary search indicates a is our current object, because binary search is pointing to a object only. So this dot node data means a current object has the node data property. Please read the value present in node data, which is nothing but 56. Okay, so this 56 will again assign to current node value. So if I hover, you can see current node value became 56. Then again we are comparing, and I hope you understand how compare to method works. So you simply you put here minus and you will be able to understand. You don't need to find exact mathematical result. You just check the sign and you will get to know whether it will return -1 +1 or 0. For example, again, like this is 56 and you put dot in place of compare to, you put it, don't need to write here. This is not an official approach to subtract, but just for the sake of simplicity, just to decide quickly what will be the return of compare to, you put it minus and then item is 75. So 56 minus 75, of course result will be in negative. So if this is the case, compare to will return you -1. Okay, so this expression will evaluate to -1. -1 is greater than 0, condition became false, so control will jump to else block. I hope you are getting me. Okay, and now in this else block, if you see this dot right tree, so this dot right tree, basically right tree of which object? This object. This means current object. Current object means which object? The one that you are accessing using binary search, means this binary search is pointing to a object. So this a object is our current object. Okay, so it is saying कि please read the property value of right tree present in a object, in our example, or root object. Okay, so right tree has value, null. If you see, so null, this we got to know that this is a null, and null is equal to null, condition became true. Okay, so control will go inside if block, and here if you see, one more object is getting created with value 75. Okay, as usual, constructor call will take place and this node data will be initializing their value. If I show you, so this node data has value 75. Left tree will remain their default value null, and right tree will also remain in their default state null. And then after creating this object, they will return the address, and that address will stored inside this. If I try drawing the diagram here, one object will be creating inside that, and then node data. So node data will have value, what was that? It is 75, right? So node data will have the value 70 5, and then LTRT. LT stand for left tree will remain in their default value, and RT as well will have their default value. Okay, and let's assume they will have some address 3000. Object we can consider name as C. Okay, and this 3000 will be stored in which variable? Right tree. Question is which right tree? We have a lot of right tree. If you see, A object have also right tree, B object also have right tree, C also have right tree. So where exactly we will have? So this, at this point of time, guys, make sure you have very good understanding of this. So if you understand this, you will never get confused. This always point to current object. So which is our current object? Our current object is A, because we called using binary search, and binary search is pointing to A object. Okay, so write tree of a object where it is null, but now this one will be keeping the address of C object, which is nothing but 3000. So here 3000 will be stored, and if I draw the diagram, so this is how basically will be happening. So this is our CF. This is what will happen. Then if we go now, if block executed, so else block will be escaped, and this way we are done. Again, if you see guys, binary search dot insert, we are calling insert method. I would like to ask you, can you tell me insert method is getting called for which object? We have a lot of object B, C, A, right? So which object we are trying to insert? The one which is being pointed by binary search reference variable. And you know binary search is pointing to a object, right? So our current object again will be initialized to a. Okay, so whenever you will see this means a object only. So for binary search we are inserting 29. Let's trace the code, and again item became 29. Then here this dot node data, our current object, this means current object, and current object is nothing but the one which is pointed by binary search, that is a object. So inside a object, what is the value of node data? 56. So this 56 will be initialized to this current node value, which will be 56. Okay, then again I will say 56 dot compare to 29, means it will return, since this first instance is greater than, so compare to will return +1. You can use the trick also, like 56 and then minus and then 29. So 56 minus 29, it will also give you the positive number, and positive result means it will give you +1. So this evaluated to +1, and +1, 1 is greater than 0. Of course 1 is greater than 0. Control will go in this if, and now this dot left tree equal to null. This again guys, don't get confused, never get confused about this keyword. So this means current object, and current object means the one which is root object, a object that is being pointed by binary search. So it is saying कि go and read the left tree property of current object or root object or a object. Okay, so left tree, if you see, of a object has 2000, right, in our example. So it is not null. So 2000, as per our example, 2000 is equal to null, means some memory address is equal to null. No, that is not null. Condition became false. See guys, this 1000, 2000, I am taking arbitrarily. Okay, this is not the address, but this is, you have to assume that this is some memory address. Okay, this is not the exact value, it is not the numeric value, it is some address. It will be in form of, it can contain alphanumeric values. Okay, but I just for the sake of simplicity I am taking numeric values. So this became, in our example, it is 2000 is equal to null. Condition became false. Control will go to else block. Okay, if I press F11, you can see control came to else block. And then here, basically, we have this dot left tree dot insert. People always get confused here, so make sure you are not getting confused. You little bit need to pay attention. How will you pay attention? See, actually here guys, what are we doing, that you have to understand. This dot left tree dot insert means कि this is current object. You can read this dot as go to that object. Okay, so this means current object, which is a object, and dot means go to which object, a object, and in that read the value present in left tree. Okay, so what is the value in left tree? 2000, or address of b object. Okay, so this is the 2000, and then dot means again go to that object. Which object? The object whose address is stored in a left tree, that is 2000. So go at that object and then call the insert method. I repeat, this dot left tree will have the address of b object. Okay, because if you see, left tree is holding the address of 2000, that is the address of b object, and dot means go at that object. So now you came at object b, and then this insert method is getting called for object b. Okay, so you have to keep in mind that now you are not on a object, you came to B object. Means I'm trying to say कि now this keyword will be pointing to again current object only, but this time your current object got changed. Earlier it was A because we call the insert method for binary search, but this time we are calling the insert method not for A object, this is for B object, because this dot left tree, this is means A object, left tree of A object has address of 2000. If you see, this is the 2000, okay, and this you came to this object, and then we are calling the insert method of this object. So now you are on object B, okay, so means your current object became B now. And then if you see insert method, this method means insert method is calling again the self. This is a recursion, you can say, where a method call itself, okay. So within the method you can see again we are calling the same method. This is called a concept called a recursion. So again control will go at top with item 29, okay. So here you can see 29, and then this dot node data, can you tell me this time what will be the value of node data? The value of node data will be, guys, actually 31. The reason is this keyword always point to current object, and this time because of this syntax our current object changed from A to B. We are now on B object, okay. So current object became B, and that's why this will always be pointing to current object, that is B object. So node data of B object has value 31. So this time if I hover on node data, you will get the value 31, okay. Then again I will say F11, and here if you see current node value has value 31 and item is 29, okay. So you can say 31 compared to 29, instance is greater. So if instance value is greater, compared to will return positive number, or you can use your own trick, 31 then minus, and then item is 29, that is 31 minus 29 will be 2, okay. But you don't have to go with result 2. Actually 2 means what, this is big positive number, right? So you just take the sign and assume कि in this case compare to will return 1 plus 1, okay. Positive, you just have to when you are putting the minus, you just have to focus on sign, not the value that you are getting after mathematical subtraction, okay. So sign, so 31 minus 29 will return positive number, so it will be a plus 1, and 1 is greater than 0, condition became true, okay. So control will go inside this. Now you have this dot left tree equal to null. You know very well, currently this means not A object, this means your current object, and your current object is nothing but B object, okay. So left tree of B object, can you check what is the value? The left tree of B object has value null. So this evaluated to null, null is equal to null. Yes, condition became true. Control will go inside the if block, and here you can see one more object will be created with value 29. If I press F11, constructor will call, and these variables will initialize. So this will initialize to 29. Left tree and right tree will remain in their default value, that is null. I will quickly press F11, and you can see this node data value became 29, and this left tree and right tree will set in their default state null, okay. So quickly I will draw one diagram here. Here one diagram I will draw, and I will say node data. So here I will have node data is set to 29, okay, and then LT. I keep writing LT stand for left tree, okay. So you know this very well. It will be null, and RT will also be null. Okay, and as usual they will have some address, so maybe 4000, and object name you can consider as D. So this object got created. When object gets created, basically they have actually, they have, it will return some address, and that address will store to where? Left tree. In which left tree? We have a lot of left tree, right? In fact, every object has a left tree. So which left tree, guys? The left tree which is pointed by this variable. This point to which object? Current object. And currently we are on which object? We are on B object. Means left tree of B object will be holding the address of D object, that is 4000. So this null will be overridden with a new value called 4000. So this is the address. Diagrammatically, if I draw the arrow, so something like this will be happening. Okay, so this is what will happen. Now if this if condition is true, this else will be escaped, and since this if was true, so this else will be escaped. I will say F10 here, and control came out of this. Then if you remember, this dot left tree, control came here also. Why? Because this was the line from where we switched from A object to B object, right? Earlier this was pointing to A object. Then we told कि this dot left tree means left tree of A object was pointing to B object, and then we came to B object by dot, and then we called the insert method. Means insert method was executing to where? Insert method was executing for B object so far, and now this completed their execution. So here this record will be inserted with value 29. Then we will check for one more, that is 42 quickly. So this is insert 42, and again guys, you will say ki earlier we were on B object, but here can you tell me currently we are again on which object? You don't need to keep extra mind, you don't apply extra mind, just see things and you will guess. Binary search dot insert, so this insert method is getting to be called for which object? The object which is being pointed by binary search. If you see, binary search is pointing to A object, it means insert method will be called for which object? A object. Okay, neither B nor C nor D, it will be for A object only. Means I am trying to say, again our current object became A object only. Okay, so whenever you will see currently this means current object, and current object is nothing but A object. Okay, so I will say F11, and here again this means current object, and node data will be of A object, that is nothing but 56. So here if you see, it is 56. So 56 will be compared here. 56 you can say minus, and then 42. Okay, so 56 minus 42, you will get I think 14, but you don't need to stick with result. 14 is a positive number, so it will give you 1. So 1 is greater than 0, condition became true, and so result, a control came inside this. Now uh, so now it will come inside this, and here again check this dot left tree. You know very well what is this current object. What is your current object? Nothing but A object. So a left tree of A object is null. No, it is 2000, right? So in our example it became 2000. 2000 is equal to null, condition became false. Control will go inside the else block. And again be careful, I hope this time you understand what exactly will be happening. So this dot left, this means current object which is A object, dot left tree. Left tree means the one which has 2000 address, that is B object. So go at B object and call the insert method for which object? for B object. So now insert method will again be called, but this time this method will be called for which object? B object. Means we came to B object again. Okay. So now when we came to B object, I'm trying to tell, you know what, that this now will again start pointing to B object. All you need to do is you have to understand the mechanism of this. You can't say this always will be pointing to same object, but yes, this will always be pointing to current object. You have to decide or you are currently on which object. Like in our example, we came to B object from A object because of this syntax. Okay, because left tree of A object is pointing to B, and we are calling insert method for B object. So we came to B object. Now this time insert method will execute for B object. You see, when I press F11, control came, and this method is going to be executed for B object. Okay, so I will press F11, and here this dot node data. I hope this time you should not get confused. Node data will not be 56, it will be 31. The reason is this is pointing to B object, and we are saying this dot node data means node data of B object. If I hover, it is 31. Okay, so 31 will be assigned to current node value. Then current node value 31 compared to 42 means 31 minus 42, the result will be negative, and negative means this one compared to method will return -1. -1 is greater than 0. No, condition became false. Control will come inside the else block. Okay, and here this else block will execute. So press F11, and this dot write tree. You just need to keep in mind that this is pointing to B object. So write tree of B object. Please check in diagram and let me know. So write tree of B object is null. Okay. So this evaluated to null. Null is equal to null. Condition became true, right? So it will come inside the if block, and here one more object will be created. If I quickly press F11, you can see constructor call will take place, and in constructor we are initializing value 42 to this node data. So they will have 42 here, and then left tree and right tree, this will have null values. Okay, so here one more object will be created. Okay, here we are on B object. So in the right of B object, this one will be created, and inside that node data will have value 42, right? I think, let me check, item what, 42. Yes, it will be 42. And then I will write in sort left tree as LT, which will be null. RT I will write as right tree, which again will be null. They will have some address which will be 5000, or anything address you can take. Okay, and maybe we can take the name of this object as E object. Okay, so this is what basically you will have, and on that we are saying that the address of this object should assign to which variable? A right tree of current object, which is B object. Means their address, which is nothing but 5000, should assign to right tree of B object. Means right tree of B object, which is nothing but here at this. So this RT will have value 5000. Okay, and diagrammatically if I show you, so this reference variable will start pointing to this object. Okay, so this is what basically will be happening on the execution of that, and else block will be escaped. Now it will go to here, because this is something from where control went to B object, and you know the insert method was called, so it returned back. After executing this, control will go back to main method. This way we became able to insert. Likewise, you know, 67 will also be inserting. As of now you understood, we traced 4 times, so I will comment it out. Okay, in order to avoid, because now you have a good understanding that how these things will work. So now since these records inserted, theoretically if you want you can try for other object as well based on the approaches that we did, like 5. Okay, so 5, if you want to insert, what you can see, first comparison will be done from root node. So if number is lesser, the input number is lesser, it will switch to left. If the input number is bigger, it will go to right side. So 5 is lesser than 56, yes, will come to left. In left, B is there. So 5 will be compared to 31 now. So 5 is lesser than 31. Yes. So it will switch to left, which is 29. Again, here also it will be compared. So 5 is less than 29. Yes. So it will come to left side. Means here 5 will be inserted. You can assume one object will be created. They will have node data. In node data value will be 5, and LTRT of this object will be null in beginning. Okay, they will have some address. Other thing you can assume. I am just in short, I am drawing like this, and this LT will point to this. Likewise, if you want to add suppose 9, so where 9 will sit, simply you again start comparing from top. So 9 is lesser than 56, yes, control will come to left. So 9 is lesser than 31 because comparison will take place with 31. Yes, this is also lesser, so will come to left. 9 will be compared with 29 also. Okay, so it will come to left only, and in left it is 5. So 9 will be compared with this 5, and 9 is lesser. No, 9 is bigger than 5. So if number is bigger, the number will be going to right side. Okay, so here 9 will be inserted. Likewise, you can check for 165, maybe let's check for 165, and then we will proceed. So 165, again comparison will take place from the top root node. So 105, it is 105, right? 165. So 165 is greater than 56, yes. If it is lesser, then only will go to left side. But this time 165 became greater, so it will switch to right side. Right side already 75 is there, so 165 will be compared with 75, which is again greater, right? So in greater means will go to right side of 75, and here 165 will be inserted. So this is how records basically gets inserted in binary search tree. Okay, I hope it makes sense. So let's go and now try to understand the concept of display, like how basically display will take place. In order to understand the display, what you can do, basically display means the it will start from the leftmost element. So first go to, if A's left has B has the left D, so it will come to D. Then the way of reading is left, root, and right, then again left, root, right. This way control will execute. So let's see how we have written the logic. So control will come to display method. Okay, I will press F11, and let's trace this code like how it will be executing. So again, this dot left tree, and you know very well, see how will you get to know this is pointing to which object currently? You can see display method is getting called for which object? Binary search object, the object which is being pointed by binary search, and binary search is pointing to a object. So our current object became A only. So here this will be pointing to A. So left tree of A is not equal to null. In our example, if you see, yes, it is 2000. In our example, we have taken the address of B. So yes, this is in our example 2000, which is not equal to null. Condition became true. So it will come inside this, and here again recursion is happening, means this method is again calling itself internally. Okay, but thing that again you should keep in mind is this way that you are calling, so you are saying this which is current object, which is nothing but a object. So dot means go at that object. So go at object A, and read the value value present in left tree. So in left tree address is 2000. So this will value became 2000. Now dot again means go at which object? The object whose address is 2000. Okay, so on 2000 object, that is nothing but b object, and then call the display method. So I hope you understand this time. This display method will be called for b object, and our object also got changed. Now we came on b object, we are standing on b object. Okay, so display method will be called for b object. Control again will come to line number 48. Okay, so if you see, it came, and this time display is going to be called for b object. Then again this dot left tree. So which left tree, guys? Currently this is pointing to b object, so left tree of b object, that is nothing but it is 4000 currently, right? So here 4000, in our example it is 4000 is not equal to null. Condition again became true. So here, again we are calling one more time method, and this time you are saying this dot left tree. So this means b object and then left tree. So b left tree present in b object has 4000 address, and then you are saying ki go to the 4000 address, means the object whose address is 4000. Please go at that object and then call the display method for that object. Means now our current object became d object. Okay, so I'm trying to say this time this point will start pointing to d object. Understood? So display method will be called for d object, and then this dot left tree. So if you see that this dot left tree means left tree of d object, okay, is null. If you say yes, it is null. Actually, yeah, just for the understanding purpose, I draw you in code we have not added. If you see in code we commented, so just to make you understand, I added this. So let's ignore as of now these values. Okay, just we will assume only, we will trace the code till d only. So left tree, if you see here, here left tree. Okay, so this condition will be this dot left tree, means the left tree of d object is null, right? So this evaluated to null. Null is not equal to null, condition became false. Understood? So here it will come and it will print this dot node data dot to string. So basically this dot node data means this will point to current object. Challenge is which is our current object? Current object is d object. Okay, so d or node data of d object is 29, and to a string basically will be converting numeric 29 into a string format, and it will print 29. Okay, so that value will be printed. You can see on the console 29 got printed, and then this dot right tree, again this is pointing to current object which is d object only. Check their right tree, so still it is null, right? Right tree of d object is null. So this evaluated to null. Null is not equal to null. This condition became false. So control will escape out of that, and then here it came here, means do you know, this was the line from where we came to d object from b object. Since d object processed successfully, control came here back, means कि control came here back to b object. Okay, by going this is what the meaning of this one is. So control went back to b object, and now since control after processing d object, control went back to b object. So now your current object again became b only, and when current object is b, means this dot node data will be the node data of b object, that is nothing but 31, right? So if I hover, you can see it is printing 31. It will be converted into a string, and that will be printed on console. If I show you, so you can see Okay, so actually, control having I have some issues with my Visual Studio. So, but assume that value will be printed. Okay, so that 31 will be printed. I will show you the result in final execution. Okay, as of now, or so it will be, or it's better. Let me stop and then execute it again so that you can understand it properly. Okay. So I will we were here, so I will directly put breakpoint here. I will remove from here. I will say continue, and then I will say actually go. So it will go. Okay, I will directly execute this. Okay, I will continue, and you see in second iteration it printed 31. Okay, so when it printed 31 it was there. Let's go, and basically with here again control will be executing. So I will say it's better, let me execute one, let me try one more time. Okay, because if I will be executing in debug mode, that will make sense for you. So I will quickly say F11, it will go, it will execute, and here it is printing 56. Okay, so 56 will be printed. Then here, okay, just a second guys, actually something is going wrong. So I will trace it again with F11, and now this dot left tree. Oh, okay. So left tree basically again we need to do from a scratch, means this dot left tree became true. As I told you, this one means something, the display will be come to B object. Okay, then with that again it will go, and this time again it came to D object, and then here again it will come. So D object no data, that 29 was printed. Then here right tree is null. So here I mean D ka right tree jo tha, that was null. That's why this condition became false. So it escaped. Then control came back to here, and this dot left tree dot display means since control went to the D object from this line only. So now control will go back to B object, means now this will be pointing to B object. Okay, and then when we will go next to that, so this dot node data, since control went back to B object, this time node dot data will have value 31. Okay, it will print 31 and come to next. So this dot right tree variable of B object is 5000. Okay, in our example, so 5000 is not equal to null, condition became true. It will come inside if, and here again you see now we will go to next object. This dot right tree has 5000, correct? So we will come to E object now, and in E object display will be called. So you understand, I'm trying to say our current object will be E. Okay, and display method will be called for E object this time. So this dot left tree, you understand our current object is E. So this dot left tree, if you see, means left tree of E object is null, right? So this evaluated to null, null is not equal to null, condition became false. So this if will be escaped, and here this dot node data, this means current object, and we are currently on object E. Okay, so E node data of E object, that is 42, will be printed. After that right tree of E object, which is again null. Okay, so this evaluated to null, null is not equal to null, condition became false. Okay, and now control came here, because if you remember last time this was the syntax because of which we came to E object from B object. Control again came to this, indicates now control is going back to their previous position. Okay, so B object. So after this line, control went back to B object, and then here this dot left tree dot display, since E object was processed, control went back to B object. In fact, B object is also processed, right? And that's why 31 was printed. So everything is done. So now control is here, which indicates again control will go back to their previous object from where you came to B object. And you know, we came to B object from A object only. So control on this line will go to A object, okay? And this time, this will be pointing to A object of node data, which is nothing but 56 will be printing, okay? And then this dot write tree, which is nothing but write tree of A object is 3000 in our example. So 3000 is not equal to null. Condition became true. Agree? So 3000 is not equal to null. Control will come in. So if, and then here again we need to switch to another object. This dot write tree means write tree has value 3000, so go at the address of 3000, and for that object called display method. So display method will be called for C object this time, and you came to C object means current object became C object. This will point to C object now. Control will go to line number 40, 48 again, and this display method is getting to be called for object, which object? For C object, okay? And now this dot left tree, so left tree of which object? Basically C object, which is null, right? So null is not equal to null, condition became false. So control will come to next line, and this dot node data, so node data of which object? C object, because currently we are standing on this object. Our current object is C, so node data has value 75. So 75 will be printed, and then this dot write tree, so write tree of current object, that is C object, is still null, ignoring this object, okay? Don't assume this one. So it is null. So this became null. Null is not equal to null, condition became false, so they will not execute. And you remember, do you remember, we came to this object because of this line. So since that executed, control now will go again to line number 56. If I press F11, you see it is coming to that, means ki from where you came to C object, control went back to their previous object, that is A object. Understood? And then it processed. So now everything processed and our entire record got displayed. So this is how basically record get inserted, and this is how record get displayed in that one.